So we're going to end our unit on measurement, dealing with some measurements and conversions. We're going to start off by just listing a whole bunch of different measurement units up there, mainly because there's some units we use in the medical fields that you may not be familiar with. I'm just going to assume you know the units for length, inches, feet, and stuff like that. And for weight, you're going to know most of these, but we're going to start off with ones you know, the ton. Of course, a standard ton is 2,000 pounds. If you want to get technical, that is actually what's called a short or a net ton. There is something called a gross or a long ton that is slightly larger than that. It's actually 2,240 pounds, but that never gets used in practice. But I threw it out there just so you're aware that there might actually be another interpretation of a ton. Of course, 2,000 pounds, smaller than a pound. Our abbreviation for pound is actually LB. The reason for that is pounds were mostly used in buying and selling grain. And in the bookkeeping for buying and selling grain, the abbreviation PD, which would make sense for pound, was already being used for paid. So the LB comes from the Latin word libra, which is the Latin word for pound. Smaller than 1 pound, we have ounces. And there are 16 ounces in 1 pound. Smaller than an ounce, the abbreviation for ounce is OZ, which also comes from the Latin word for ounce, which I can't think of right now. So we're going to just leave it at that. It's OZ. Smaller than an ounce, there's something called a dram. There are 16 drams in an ounce. The dram actually was originally from the Greek coin, the drachma. That was actually the weight of that Greek coin, about 1/16 of an ounce. So the dram was one of the original apothecary units. You might be prescribed an 1/8 of a dram or a 1/16 of a dram of medication. Now there are units smaller than that. They often get put into the fluid units. There are grains that are going to be brought into that. Grains have kind of been absorbed from the standard measurement system into the metric measurement system now, though. So we're going to include those when we talk about the metric system. So those are our units of weight that are of interest to us. Let's talk also then about, oh, by the way, you hear a lot on the news about gold reaching $1,800 an ounce or $2,000 an ounce. When you're talking about precious metals, we are not talking about the pounds and ounces that we're used to here. In precious metals, they actually use troy measurement. Troy measurement actually comes from the Greek island of Troy. In the troy measurement, 1 troy pound is about 0.83 regular pounds. But 1 troy pound is only 12 troy ounces. So a troy pound is actually slightly smaller than a regular pound. But a troy ounce is actually slightly larger than a regular ounce. So when you're talking about gold and silver, which you're hearing the prices on the news, those are the units they're talking about. We're not going to ever be tested on those numbers, but I just wanted to make you aware that there are other slightly different units out there that get used. So if we talk about volume, again, we'll start out with the units that you're already familiar with, like a gallon. A lot of units larger than a gallon, like a hogshead or a bushel or a barrel. Medical fields, we're not really interested in those larger units. So as you go smaller than a gallon, the next is called a quart. Now the word quart actually comes from the word quarter, which implies that it's 1/4, or there are 4 of them in a gallon. Smaller than a quart. There's pints. There are 2 pints in a quart. And smaller than a pint, there are cups. And there are 2 cups in a pint. A cup sometimes used to be referred to as a half pint, which makes sense that there's 2 of them. Now there are units smaller than cups. 1 cup is 8 fluid ounces. It is important to point out that a fluid ounce is not a unit of weight. 1 fluid ounce and 1 ounce are not necessarily the same thing. When you're dealing with water, 1 fluid ounce of water is relatively close to 1 ounce. But it is a unit of volume, not weight anymore. In fact, as we go smaller than that, 1 fluid ounce, in weight, 1 ounce is 16 grams. But when we're talking about volume, this is where it gets really confusing. 1 fluid ounce is only 8 fluid grams. So that is part of the reason why grams have kind of been eliminated from the apothecary unit system, because that confusion of 16 grams in an ounce, but only 8 fluid grams in a fluid ounce. So we're not going to use that conversion a whole lot. There are some other units smaller than a fluid ounce. 1 fluid ounce is 2 tablespoons. And 1 tablespoon, I'm going to use the long abbreviation for tablespoon, is 3 teaspoons. A note that should be made there. Tablespoons and teaspoons are a long ways from having standardized abbreviations. Each of them has several acceptable abbreviations. Probably the most commonly used one now is a capital T and a small t, where the capital T is tablespoons, the small t is teaspoons. Another popular one was capital TSP for tablespoons, small tsp for teaspoons. The one I was always familiar with was TBSP for tablespoons, with either a small or a capital T. It can be kind of confusing because those abbreviations are so much alike. The biggest thing is to look for the capital T. I've screwed that up a couple of times the hard way. Trust me, when your recipe for cookies calls for 3 teaspoons of salt and you accidentally hit 3 tablespoons, you do notice the difference. There are some units smaller than that. You don't need to write these down. I'm just going to throw them out there for fun. Smaller than a teaspoon. 1 teaspoon is 2 dashes. 1 dash is 3 pinches. And 1 pinch is 2 smidgens. You may have heard those talked about on, if you ever watch a cooking show or hear someone talk about cooking, a pinch of this or a dash of that. Those are actually units. You can actually get little measuring spoons for them. The pinch is just what it sounds like. You reach in and grab a pinch between your fingers. The smidgen I always thought was kind of nasty. You stick your finger in there, whatever sticks to your finger is a smidgen. So anyway, we're not going to run into those a whole lot in the medical fields, but throw them out there for general knowledge for you. Now there are then other units that come into play here. There's something called a minim. A minim was one of the original apothecary units in the standard system. There were 60 minims in 1 fluid gram. So if there's 8 fluid grams in a fluid ounce, that meant there was 480 minims in 1 fluid ounce. The minim was actually the standard for measuring medications for a long, long time. Grains, which, like I said, we're now going to put those into the metric system, was also a pretty good one. So anyway, that's about it for our standard units of measurement that we're really concerned about. Let's take a look at converting. If I want to convert from, let's say I have, let's put out a unit here that we're not real familiar with, 96 grams, and I want to know how many ounces that is. Now, many of you have probably done conversions enough. You can just look at it, find a conversion factor, and decide whether you divide or you multiply. Of course, the biggest thing there is you look at the units. A gram and an ounce. Well, the ounce is bigger than a gram, so the unit is getting larger, which means the number has to get smaller. So that tells us that we're going to divide by whatever that conversion factor is to make that number smaller. The formal way of doing this, of setting it up, we're going to take our 96 grams. We're going to make it a fraction by putting it over 1. Now in our conversion factor, we want to get rid of drams. Since drams are on top, we're going to put drams on bottom in our conversion factor so that they will cross-cancel out when we multiply the fractions. We're going to put ounces then on top so that we end up with ounces in our answer. And our conversion, or our equivalency, says that 1 ounce is 16 grams when we're talking about weight. So now, like I said, the grams are canceled out. We have 96 times 1 ounce is 96 ounces. 1 times 16 is 16. 96 ounces divided by 16 is 6 ounces. So 96 grams is 6 ounces. In the metric system, things are a lot simpler. We have, in our metric system, only one unit of mass, and that is a gram. We have only one unit of volume, that is the liter. The gram is abbreviated with just a G. The liter is abbreviated with just an L. Now, when I was in school, we were always taught to abbreviate liter with a capital L. The reason for that was, at that time, on the common fonts that were used, a small L and a 1 were nearly identical. So if you had like 8 liters, you didn't want any confusion of, is that 8 liters or is that 81? So if you made that a capital L, it was very clear that was 8 liters. Well, now with all the computer type fonts and stuff, in most of those fonts, the 1 and the small L are different enough that you can tell the difference. So it is now okay to use a small L to abbreviate liters. But just so you know, you're always going to see me use a capital L most likely just because that's what I'm used to. Now as we get smaller, if we need to measure something smaller than a gram or a liter, we use metric prefixes. The metric prefix deci means 1/10. So a decigram or a deciliter would be 1/10 of a gram or 1/10 of a liter. The prefix centi means 1/100th. So CG would be centigram, CL would be centiliter. That's 1/100th of a gram or 1/100th of a liter. And then the prefix milli means 1/1000th. So mg would be milligram, which is 1,000th of a gram. ml would be milliliter, 1,000th of a liter. From there, we do have smaller units, smaller prefixes we use, but we don't go every 10 anymore. Instead of going 10, 100, 1,000, 10,000, we skip from 1,000 up to 1,000,000. So I'm just going to leave 2 little blank spots there. 1/1,000,000th is micro. Now the abbreviation, the technical abbreviation for micro is the Greek letter mu, which looks like that. However, in the medical fields, almost everything gets keyboarded into the computer, and it has for about 30, 35 years now. There's no key on the computer for the Greek letter mu. So to enter that in would be a real pain. So in the medical fields, they've accepted MC as the abbreviation for micro. So MCG would be a microgram or a millionth of a gram. MCL would be a microliter or a millionth of a liter. If we were to keep going, again, it would go every 1,000 instead of every 10. And so the next one would be 1/1000th of a gram or 1/100000th of a liter. That would be nano. You may have heard a lot about nanotechnology in the news in recent years. All nanotechnology is, it's actually referring to a nanometer, which is a billionth of a meter. Most atoms are right around the size of a nanometer. In fact, many of them are a little bit smaller, a little bit larger than a nanometer in size. So when they're talking about nanotechnology, all they're really talking about is the technology of things that are really, really small. And basically building things atom by atom instead of with other conventional methods. There are units smaller than nano, like fempico and femto, and stuff like that, but we're not going to get into those. Going larger from our standard units in the metric system, we have deca. Deca means 10. Now, DG and DL has already been used for deci, so they use DA for deca. So DAG or DAL would be a decagram or a decaliter, so 10 grams or 10 liters. Next is hecto, which is 100. So HG is a hectogram, which is 100 grams. HL is a hectoliter or 100 liters. And then next would be kilo, which is 1,000. So a kilogram, kg, is 1,000 grams. Kiloliter, KL, is 1,000 liters. Now, just like on the other end, it doesn't go every 10 anymore. It skips by thousands. So we would skip up to 1,000 here. The next one would be mega. Notice I used a capital L there, or capital M there, sorry. Mega means a million. And when you abbreviate mega, since M has been used for milli and would be also used for meters, for mega we use a capital M. So capital MG would be a megagram, or a million grams. Capital ML would be a megaliter, or a million liters. And then, of course, bigger than mega, there's giga and tera and other prefixes that come into it. For the medical fields, again, this is more than enough range for what we need. Now, they developed all of these units here. What they've come to find out, the deca and the hecto didn't really get used at all. They weren't very practical. They're just too overcrowded. Didn't need every 10 units. So grams and liters got used a lot. Kilograms, kiloliters. Kiloliters themselves are actually pretty large too, but kilograms and kiloliters got used some. On the other end, the milligrams and milliliters got used a lot. And the deci and the centi did not get used near as much. Now, I'm not crossing them off because they do have some uses. In the medical fields, a deciliter gets used quite a bit for whenever they do blood draws and blood testing. And when you get your results for your cholesterol, you might have like a 180 or whatever for your cholesterol reading. That is milligrams per deciliter of blood. Or if you do a blood glucose test, a blood sugar test, and you get a reading of 85, that is 85 milligrams of blood glucose per deciliter of blood. So in the medical fields, deci does get used some for the blood testing. Centi does not get used much. Medical fields, not much at all. But in the United States, it caught on because we're so ingrained in the feet and the inches for length measurement that the centimeter is the unit of length in the metric system that happens to be closest to our inch. So it was what was comfortable to a lot of people, and it caught on in the United States. In other countries that are more ingrained in the metric system, the centimeter is not that heavily used. So the main ones, every 1,000, are the ones that get the most use. Conversions within the metric system are actually quite simple. Because each spot on this chart is either getting smaller by multiplying by 10 or dividing by 10, that's all you have to do to convert. In fact, when you multiply or divide by 10, all it does is move the decimal point over a spot. So let's say I had to convert 420 milligrams into grams. Well, on my chart, I'm moving from milligrams to grams is 1, 2, 3 spots to the left. The decimal point on my measurement has to move 1, 2, 3 spots to the left. That is 0.42 grams. Or I might have 2.48 liters, and I want to change that into deciliters. On my chart, going from liters to deciliters is 1 spot to the right. My decimal point has to move 1 spot to the right. That becomes 24.8 deciliters. I'm not going to spend a lot of time on that because I'm going to assume that all of you know how to do conversions within the metric system. What we do need to know how to do, though, is some other units that are not necessarily normally within the metric system. We talked about grains. Grains were originally in the standard unit that was absorbed into the metric system for medical purposes. 1 gram is equal to approximately 15 grains. This is approximate. It's actually like 15.6 or something like that. It's a really weird number. It's been rounded to 15 just to make it a smoother, easier conversion. Now, because of that rounding, 1 grain is equal to about 60 milligrams. Again, this is like 62.1 or 62 milligrams would be more accurate. But they rounded it off to make it a smoother, easier conversion. If you do the math here, however, you know there's 1,000 milligrams in a gram. But if you multiply it out, 15 times 60 is only 900. So that would be saying only 900 milligrams in a gram, which of course is off. And that again is because of that round off when they absorb the grains into the metric system. So you can see the grains themselves are not a very precise conversion within the metric system. They've been absorbed into it because there's still enough medication that's measured out in grains that it had to be put into our medical system. Pretty much all of the medical calculations and dosages now have gone metric. The minims come into it. We talked about 60 minims in a fluid dram or 480 minims in a fluid ounce. Well, 1 milliliter is going to be 16 minims. So now, along with our conversions of these standard units that have been absorbed into the metric system, we do also need to be able to convert between the metric and standard units. Sticking with the volume here with the milliliters, 1 fluid ounce is approximately 30 milliliters. Now I say approximately. In your textbook, about 2 pages apart, it gives you different conversions from fluid ounces to milliliters. On one page it says 1 fluid ounce is 30 milliliters. A few pages later, it says 1 fluid ounce is 29.9 milliliters. I will accept answers on the test either way. 30 is just a lot easier to work with. Back on the weight side of things, 1 kilogram, which seems to be the standard unit of, it's actually a unit of mass in the metric system, but we take it to be a unit of weight, or we use it as a unit of weight, is about 2.2 pounds. So if we have to do some conversions within systems, let's say that we have a patient who weighs 98 pounds, and we want to know how many kilograms that patient is. Well, back to the conversion that we used way back at the beginning with the standard units. I'm going to make this into a fraction. 98 pounds over 1. About pounds on bottom, kilograms on top. 1 kilogram is 2.2 pounds. The pounds will cross cancel out. This is 98 times 1 kilogram is 98 kilograms. 1 times 2.2 is 2.2. So you can see it's going to be 98 divided by 2.2. 44.55 pounds. Or 44.55 kilograms, I should say. What you can see here is basically, once you get to this point, all that's going to happen is we're taking our weight in pounds and we're dividing by 2.2 to turn it into kilograms. That conversion happens enough in medicine that that's an accepted shortcut. It's a very common shortcut. You're just going to multiply by 2.2. So if a patient comes in at 132 pounds, to convert them into kilograms, we're going to divide by 2.2 and get 60 kilograms. If you have a dosage that is given as 1 1/2 fluid ounces, and we need to figure out, okay, all of our syringes are measured in milliliters. What dosage are we going to give? So 1 1/2 fluid ounces. We're just going to put it over 1 to make it a fraction again. Even though it's already a fraction, we can still put it over 1 like that. We're going to put fluid ounces on bottom, milliliters on top. And we know that 1 fluid ounce is 30 milliliters. Now the fluid ounces will cross cancel. 1.5 times 30 milliliters is 45 milliliters. 1 times 1 is 1. So since that's over 1, that's just going to be 45 milliliters. So now again, those conversions are simple enough. I'm going to trust that you guys have worked with measurement conversions enough to do those. What I want to look at now is a little bit more complex conversions. Like, oh, if we have, what do I put down? 80 grains into milligrams. This is one to be very careful. The reason I bring this one up specifically is the abbreviation for grains, GR. The abbreviation for grams is just G, and everybody knows that. But for some reason, when people see, and I'll get 3 or 4 people get this wrong on the test every semester, they see the GR and they think grams, because they're so used to thinking grams when we're talking about weight or mass. Be very careful that you pick that out. That is grains. So I'm going to make the fraction 80 grains over 1. And in my conversion factor, grains are going to go on bottom. And we're converting into milligrams. Well, from grains to milligrams, 1 grain is 60 milligrams. The grains cross cancel. 80 times 60 is 4,800 milligrams. So there we go. So anyway, let's look at some units maybe a little bit more complex. We might have, let's see here. 3 grams per fluid ounce. And let's convert that into, what do I do? Ounces per cup. So to do these conversions in the standard units, there are a couple of different ways we can approach it. I'm going to go with using the conversion factor method first. 3 grams per fluid ounce has to be written as 3 grams over 1 fluid ounce. We have to write it as that rate with the unit, the 1 on bottom. And now we're going to convert grams into ounces. So I have to get rid of the grams, put grams on bottom, ounces on top. 1 ounce is 16 grams. So that will cancel out the grams, and we are in ounces. I have to get rid of the fluid ounces, which will go on top. So they will cross cancel, going to cups. 1 cup is 8 fluid ounces. So now the fluid ounces are gone. Now it's just a matter of multiplying out. We have 3 times 1 ounce is 3 ounces, times 8 is 24 ounces. Over 1 times 16 is 16, times 1 cup is 16 cups. So now we have 24 divided by 16, or 1.5 ounces per cup. So we can do those multiple unit, or this is what's called a compound unit conversion, using those conversion factors. If this is in the metric system, it actually becomes a whole lot simpler. Let's say that we have something listed as 28.7 micrograms per milliliter. And we want to know how many milligrams per deciliter this is going to be. I'm going to set it up like this. 28.7 micrograms over 1 milliliter. Now your textbook talks about doing metric conversions using powers of 10. We went over that a little bit on Monday with the powers of 10 and the engineering notation and stuff like that. it can be really confusing to do conversions that way. To me, I like using that chart where you just count the spaces on the chart, move the decimal point. Now, of course, that does require, if you're going to be doing a lot of it and you don't have the textbook in front of you or notes in front of you, that does require you to memorize the units in the chart, which isn't really that horrible to do. So rather than using the conversion factors and using the powers of 10 like the textbook do, I like to just do the table, the chart, and make my conversions. We have to convert micrograms into milligrams. Well, micro to milligrams on the chart is 3 spots to the left. So I have to move my decimal point 3 spots to the left. I have to add a 0 there. So that'll be 0.0287. I also have to convert milliliters into deciliters. On the chart, milliliters to deciliters, milli to deci is 2 spots to the left. So I have to take the decimal point here, which would be after the 1, and I have to move it 2 spots to the left. So 1, 2, add a 0. That's going to be 0.01. Now also a little note, in our medical classes we require the 0 in front of the decimal point just for clarity. So anyway, we have that written out. Now, to finish this off, we want to divide this out because we do want it to be a unit rate. So we're going to divide by 0.01. Doing that division gives us 2.87. And the units will be milligrams per deciliter. We might have 390 grams per liter. Let's convert that to milligrams per milliliter. So again, this will be 390 grams over 1 liter. We're going to convert that into milligrams and milliliters. To get from grams to milliliters is 3 spots to the right on our chart. So our decimal point starts here. We're going to move 3 spots to the right, which means you have to add zeros. That's going to be 390,000. Liters to milliliters is also 3 spots to the right. So our decimal point starts after the 1. We move it 3 spots to the right, and filling in zeros is 1,000. Just like before, we want to make this a unit rate, so we're going to divide by that denominator. 390,000 divided by 1,000 is 390 milligrams per milliliter. So you can see in that case, because both units, the grams to milligrams and liters to milliliters, changed by that same factor of 1,000, the number itself didn't even change. Another conversion that we sometimes have to make is a temperature conversion. Temperature is a little bit trickier because it doesn't have a common 0 point. In all of our other units, mass, volume, whatever, for mass, 0 grams equals 0 pounds. Or for volume, 0 liters equals 0 gallons. They have a common 0 point. Nothing is nothing. But in temperature, there wasn't a standardized starting point for temperature. So the two common temperature scales ended up with different 0 points. So we have the degrees Fahrenheit scale and the degrees Celsius scale. Both of them have common benchmarks, one being where water boils and one being where water freezes. Let's stick to the Fahrenheit scale for now, which is the one we use for our weather and other stuff. At what temperature in the Fahrenheit scale does water freeze? Can somebody tell me? 32 degrees, perfect. 32 degrees Fahrenheit. What temperature does water boil in the Fahrenheit scale? Careful. It's 212 degrees in the Fahrenheit scale. On the Celsius scale, water freezes at 0 and boils at 100. Good. Now, two things you note. As we said, the 0 point is not the same. Second, between freezing and boiling, on the Celsius scale, there's 100 degrees. That's why it was sometimes called the centigrade scale, because centi means 100, grade means divisions, 100 divisions. On the Fahrenheit scale, between freezing and boiling, there's 180 degrees Fahrenheit. So not only do they have a different starting point, a different 0 point, but they also, a degree in one is different size than in the other. Now this 180 to 100 is a very important ratio, however. If we put that ratio up there, 180 over 100, it reduces to 9/5 or 9 to 5 ratio. That is important in our conversion factors. If I want to convert degrees Fahrenheit into degrees Celsius, our Celsius temperature is going to be found by taking our Fahrenheit temperature and subtracting 32 from it, because we've got to get it down to the same 0, and then multiplying by 5/9. That's just this ratio, the reverse of that ratio. It's 9 to 5, 5 to 9. Let's take an example. Human body temperature is considered to be 98.6 degrees Fahrenheit. Let's convert that to the Celsius scale. So 5/9 times 98.6 minus 32. We do our subtraction. 98.6 minus 32 is 66.6. Times 5/9 ends up being 37 degrees Celsius. So 37 degrees Celsius is equivalent to 98.6 degrees Fahrenheit. Going the other direction, to convert from degrees Celsius into degrees Fahrenheit, our Fahrenheit temperature is found by taking our Celsius temperature times 9/5, that ratio again, and then adding the 32 degrees to account for that difference in 0 point. So let's say that we are told that the temperature tomorrow is going to be 20 degrees Celsius. Is that a cold day, a warm day, or where does it fall? Well, let's do the conversion. We'll put 20 in there for the degrees Celsius. It's going to be 9/5 times 20 is 36. Plus 32 is 68 degrees. So 32 degrees Celsius is 68 degrees Fahrenheit. I would take that right about now. Okay, with that, we've got a few minutes left. It's time to make sure you guys have your homework. There are several pages here to finish this off, but they should all go pretty quickly. Some recommended work for you to make sure you have all this down. On page 110, practicing some of the conversions for weight and volume. 1 through 41, the odds. And also weight and volume metric units, page 114, 1 through 25, the odds. Some of our apothecary units and smaller household units, page 118, 1 through 19, the odds. And then the temperatures, page 123, 1 through 21, the odds. So that wraps up Unit 2. On Friday, you will have the whole hour to do the Unit 2 test. And you actually have 2 hours, so if you need more time outside of class, arrange it with your contact person there at the school and find some time to finish it up. And then we'll get our week off. So we'll see you all on Friday. Have a good day.